What's up YouTube? How's it going? Back again for another random video. I'm going to show you guys this DVD I've had for a very long time. Don't know how I got it, where I got it. It's a HQV benchmark DVD just to show you how TVs perform with the refresh rate, picture quality, the colors. I wish I could send you the link, but maybe check out something to do with this HQV benchmark DVD. So my TV is an LG LED 6200, 60 hertz, 4 HDMI inputs. Nothing too fancy, but yeah, let's watch the video.
The worldwide interest in high-definition television is spawning new and exciting entertainment products for the home. Whether your interest is in the latest sports, news, or simply a good movie, the attraction of having your own home theater installation is undeniable. United States television stations are in an ongoing process of converting their terrestrial transmissions from analog to digital signals. Many of the networks are introducing high-definition programming as a portion of their broadcast day, bringing wonderful visual content into the home. Unfortunately, few people realize when they purchase their first high-definition TV set that the majority of programming they will watch, such as TV, satellite, cable, or DVDs, won't be in high definition at all. Instead, it will be a standard definition signal simply converted and displayed in this fashion by their new high-definition TV set. This process is much like enlarging an old photograph, and often just as unsatisfying. In order to improve this entertainment experience, many television set manufacturers are incorporating advanced visual processing circuitry designed to improve signal conversion, enhance the image, and remove artifacts caused by the conversion, transmission, or display process. Not all built-in circuitry is equal in delivering the best image quality. So how can you tell whose chipset or processing algorithms supply studio-quality imagery? The best designs involve years of research to develop computing power to properly handle standard to high-definition conversions, different film and video frame rates, and noise reduction for both interlaced and progressive signals. This DVD is one way to help you decide which model best delivers on that investment. We invite you to use this DVD as a test device to evaluate the next high-definition television set or monitor that you intend to purchase. Some displays will look better than others, depending on the chipset inside. This DVD is intended as a neutral benchmark that you may use to see which brand or model best suits you. The following brief examples will demonstrate the different criteria being tested. We invite you at any time to exit to the menu and select from the individual tests or test loops for further examination. Color bar test signals are devices that television engineers use to measure color fidelity and image resolution. Take a look at the fine horizontal lines in this test signal. The small area in the upper right portion of the pattern is made up of alternating black and white lines that are only 1 pixel tall. If this image appears to be stable, then the full 480 lines of the DVD image are being properly displayed. If this portion of the screen is flickering, then effectively only half of the lines are being displayed and you are not seeing the full resolution that is available. A stable image without any flickering is considered to be passing the test. When diagonal lines are displayed on high-definition television sets, they often appear to be stair-stepped rather than smooth in appearance. We refer to this as the Jaggies, and the degree to how objectionable this is often depends on the angle of the line and the size of the television screen. Modern high-definition displays have an even tougher time correcting this phenomenon because they frequently have to convert an interlaced transmission into the progressive scan format used by projection systems and flat-panel monitors. In order to display the best image, the chipset must employ motion-adaptive deinterlacing with directional interpolation to smooth out the Jaggies at low angles. In this first test, the rotating line will appear more smooth or more jagged depending on the angle. The shallower the angle is before you feel that the jaggedness or amount of stair-stepping is noticeable, the better this set's circuitry is in processing the conversion. If the angle is between 10 degrees and 20 degrees, then the processing is average. Angles below 10 degrees are quite good, but greater than 20 degrees should be considered failing. In this second test, you'll see 3 lines moving back and forth. If all 3 lines appear jagged at all times, then the display uses no directional interpolation to smooth the images, and it is delivering poor results. If the top line is smooth but the bottom two are jagged, then this display is delivering fair performance. If the top two lines are smooth but the third one is jagged, then this display is delivering good performance. If all three lines are smooth, then the display is giving you the best interpolation that current state-of-the-art circuitry can achieve. When we watch real-life images instead of test patterns, it's often harder to see some of the artifacts caused by poor processing. However, certain shots provide good natural tests. One example of this is the United States flag with its distinct red and white stripes. As the flag blows in the wind, the stripes create a natural Jaggies test, much like our artificial rotating test pattern. The better the edges of the stripes in this flag look at all angles, the better the chipset in your display system is at processing this image. Since the majority of television programs viewed on a typical high-definition television are actually legacy standard definition content, it is important to make the most of the image, and in fact, make it appear as if the program is nearly high definition. In this scene of a bridge and foreground traffic, look closely for the level of detail in the bricks of the bridge, the statue, and the blades of grass in the lawn. If these parts of the scene appear too smooth without any fine detail, maybe even somewhat blurred, then the detail processing being applied is ineffective and you are losing the fine detail that is in the shot. Proper processing should retain obvious small texture in the bricks, the grass, and other areas of the image, and even extend the detail such that the image looks clear and sharp. Through post-production, shots, scenes, and tapes are edited and copied numerous times, frequently leading to image degradation that is a result of generation loss and a buildup of signal noise. This is especially true of older analog productions, but similar problems can arise through modern digital compression used in editing, satellite transmission, and DVD mastering. In this test, areas of solid color, such as the skies in these shots, are often places that will tend to look grainy or noisy. It is important to employ image processing to remove objectionable noise, especially in large-screen digital televisions, where random noise can quickly overpower the signal, resulting in highly degraded pictures. Poor image processing often confuses random noise with motion, applying too much correction. If this is the case, portions of the image will lag or smear, leaving visible trails. Good image processing will reduce the amount of visible noise without creating artifacts, regardless of the motion in the scene. In addition, good noise reduction will automatically clean up noisy signals, but leave clean signals unaffected without any user intervention. Shots that were captured on film and are then displayed on television create a special set of processing conditions due to the manner in which 24 frame per second film is displayed on 30 frame per second US television sets. In the test images that you see, pay close attention to the detail areas in the speedway stands and notice not only whether the detail looks good, but how quickly the processors in this television lock onto the image as the shots change. A fraction of a second for the shot to lock is acceptable, but shorter is better. The proper processing of cadence is quite difficult when there is fast horizontal motion in an image. Different film cadences will tend to appear to strobe on television displays, which is quite normal. You will see this on theater screens as well, but usually aren't as aware of it. Generally, most circuitry compensates for this motion when converting between interlaced and progressive displays, but often with a loss of detail in the image during the moving portion of the scene. Look closely at our screen sample to see whether image detail is retained. Is the detail blurred or sharp? Are diagonal lines smooth or jagged? Film material that is edited electronically for video introduces other issues. Frequently, video effects, transitions, and titles are added. Now the processing algorithms not only have to compute back to images based on an original 24 frames per second, but they must avoid getting confused by these new video-based elements. The best possible chipsets will intelligently detect between film and video, converting different portions of the image on a per-pixel basis. The worst-case example is when new rolling video credits are added to a feature film for television or DVD presentations. We hope that this series of tests using real images as examples has given you a better idea of how the circuitry and processing inside a television display can greatly affect the quality of your viewing experience. Now that you know what to look for, feel free to select any of the individual tests from the menu for your own testing. These individual tests are designed to loop, so to return to the menu to make another selection, simply press the menu button on your DVD remote control.
Well, there you have it, YouTube. Tells you all the tests, and my TV pretty much passed them all, so try to find this DVD and do it yourself. And I hope you liked that video, and I hope you like and subscribe for more random videos. And I'll talk to you later. See ya.